Okay, so as in the last video we have discussed about the acceleration of a motion under elastic restoring force, or how to find the acceleration of a mass spring system. We came out to know that acceleration would be equal to minus k upon mx, right? And the acceleration of the projection of a particle which was moving along the uniform circular path was minus x omega square, and here we have got a is equal to minus k upon mx. Now we are going to derive the formula for finding the time period of a mass spring system or time period of a motion under elastic restoring force. So what we are going to do today is we are going to find driving the formula for calculating for calculating the time period. The time period of mass spring system. Mass spring system. Calculating or driving the formula for calculating the time period of the mass spring system or motion under elastic restoring force. So initially we need to start with the general formula, and general formula for finding the time period of anything is what it is. T is equal to 2 pi over omega. Now see, this formula we can use in the uniform circular motion to find the time period of it, but this formula we cannot use in the mass spring system or in the motion under elastic restoring force, since we don't have omega here, right? Omega is what? Omega is the angular velocity. Omega is angular velocity, but we don't want here angular velocity. How we'll have here angular velocity in the mass spring system or in the motion under elastic restoring force? That's why we need to derive the formula for it. We need to derive the formula for calculating the time period of the mass spring system, right? So time period, we are starting with the general formula. T is equal to 2 pi upon omega, where omega represents the angular velocity and we need to remove it. Now see, we are going to use the formulas which we have derived for acceleration, for finding the acceleration of a projection of a particle along uniform circular path and acceleration of motion under elastic restoring force. So we are going to write here acceleration formulas. One in the projection of a particle moving along uniform circular path or you can say the connection between uniform circular motion and simple harmonic motion. And secondly, we're gonna have an acceleration formula which we have just derived for motion under elastic restoring force or Hooke's law or mass spring system. So motion under elastic restoring force. motion under elastic restoring force. Now see, initially we are going to see the formula for the acceleration of a projection of a particle moving along uniform circular path. So here we had our formula A is equal to minus x omega square, where x is the displacement from the mean position to the extreme position, since displacement is always taken away from the mean position, and omega is the angular velocity of a particle which is moving along the uniform circular path, right? And we found the formula for finding the acceleration of a motion under elastic restoring force or Hooke's law or mass spring system too, and this formula was A is equal to minus k over m x, where k is the spring constant, m is the mass of a body, x is the displacement from the mean position to the extreme position, right? Now we have written these two formulas. Now we need to compare these formulas. We need to compare these two formulas in order to get the omega, right? Since we need to remove this omega, so we need to have the value of the omega, right? So comparing both, for suppose this is equation 1, this is equation 2, we are going to compare these both now. Comparing both the equations. Or equating both the equations, right? So minus x omega square is equal to minus k over mx, right? So x cancelled with x cancel with x, minus cancel with minus, right? Omega square is equal to k over m. See, we don't need to have a value of omega square, we need to have a value of omega, right? So in order to remove this square, we need to square on both sides. So squaring on both sides, so omega is equal to under root k over m. Now we have found the value of omega, which is under root k over m. This is the value of omega, right? Now we are going to substitute the value of omega in the equation 1, which we have our general equation, t is equal to 2 pi over omega, right? So initially writing the general equation, t is equal to 2 pi over omega. Now substituting the value of omega, what we're gonna have here would be t is equal to 2 pi over under root k over m. When we solve this further, t is equal to, what we're gonna have is 2 pi under root m over k. So this is the formula for finding the time period of motion under elastic restoring force or Hooke's law, or you can say mass spring system. So this is formula for finding time period of mass spring system. Mass spring system or motion under elastic restoring force or Hooke's law. So t is equal to 2 pi under root m over k. And what we got the value of omega under root k over m, and what we found the formula for finding the time period of the motion under elastic restoring force or Hooke's law or mass spring system is T is equal to 2 pi under root m over k. K represents the Spring's constant, mass is the m is the mass of the body, and 2 pi is the numeric constant, right? So this was all for today. In the next video we're going to derive the formula for finding the frequency of mass spring system or motion under elastic restoring force.